All right. Good afternoon, everyone. I hope you are doing well. Can you indicate if you can hear me? Okay. All right. This is how we're going to move. Of course, this is solely Math 001. So we want to see how to revise and get into real question drilling on 001. So, brace up. You're going to be getting lots of tough questions, technical questions. Yeah, let's start from matrix, I guess. So let's see how we move from matrix. I want to test your ability to solve several questions on matrix. Let's spend about 10 minutes on each of the topics, just 10 minutes, and then we'll see. Let me know how much you are very much great with matrices. All right, this is the first question. Okay, it looks like the camera is not very well situated. Better, I guess. So the question says find the non-negative value of x which satisfies the equation. Now let's talk about the equation. This is the equation right here. Of course, it's not an equation if you don't have an equals to sign there. So this is the equation. All right, you have just 5 minutes to solve or less than that. Let's get right into it. And while you're solving that, I would love you to also work with this. So this is question number 1. Let's see question number 2. Okay, we have a matrix A given as this: -4, -4, 4, -1, 0, 1, -7, -6, 7. So you have to determine the value of the constant lambda so that A plus lambda I being the identity matrix, is singular. So this is question number 2. So do we have an answer for question number 1? 0 and 1. Somebody, okay, Jimmy, you said 0 and 1. 0 and 1. Are you sure about that? Okay, let's try and solve together. This is a very simple question. Uh, First of all, look at the context of the question. We're told to find a non-negative value of x. So by talking about the non-negative value, obviously you know we're interested in only the positive value of x that satisfies the equation that we see written in front of us. Now, one thing you can notice is you can see these two line brackets surrounding this matrix. This obviously tells you that you are talking about the determinant of this matrix, because this, I told you already that you could write it as determinant of A, or you could write it as determinant of A like this. Whichever way you see it, it's still determinant. So let's go on to try and solve this. Now, let's try and find the determinant of this matrix we have within here. The first thing you want to do is to have, of course, I want to use the first method, plus minus plus. So what I want to do next is to have plus x. Then, of course, you know, I'm going to isolate this and I'm left with x0, 1x. So I find the determinant of this. I'm using the first method of finding the determinant of a 3 by 3 matrix. So I'll be left with x squared minus 0. That's the determinant that came out from here. Then I have minus 1. Then, of course, I'm isolating this and this. So I'm left with 1, 0, 0x as the matrix, the 2 by 2 matrix. Finding the determinant of 1, 0, 0x matrix, that will be 1 times x. That will be x minus 0. Then the last but not the least, I will have plus 0. Then, of course, I'm isolating column 3 and row 1. I'm left with 1x, 0, 1. Finding the determinant of that 2 by 2 matrix, I have 1 minus 0. Of course, I know already that this last side will not exist because of this 0. Because 0 times anything, whatever was there, 0 times whatever was there would have cancelled the whole thing. So here I'm left with x squared. Sorry, x squared times x is x cubed minus is it minus 0 or minus 1? I don't think this was minus 0. I think, oh, looks like I wrote, oh, sorry about that. The original question, this was supposed to be 1, guys. That was supposed to be 1. So if we had, okay, let me act like that was 0. Let me solve if this was 0. So obviously it will be x cubed minus 0. Of course, that's gone. Minus x. Okay. That will be equals to 0 because of this. So this will be x into x squared minus 1 equals to 0. What's going on here is I'm just solving whatever we have here. Of course, I told you this was supposed to be 1, but let me act it was x that was, it was 0 that was there. So this is what we're going to have. X times x squared, x cubed, x times 0, that will be 0. So that will be x cubed minus 0. Of course, we don't need the minus 0 again. Minus 1, x minus 0 is x. Minus 1 times x is minus x. All this return to 0. So this is the resultant from these calculations, x cubed minus x. So what you want to do next is to isolate x, factorize x out, and you're left with x squared minus 1. Of course, looking at this, we have x being equals to 0. Then we have x squared minus 1 being equals to 0. All right. Now, if you go on to try and solve this, of course, you'll be having, this is 0. We don't want to use this because we are more concerned with the non-negative value. So we will not be putting this into our answer. X squared minus 1 equals to 0. That means x squared is equals to 1. That means x is equals to square root of 1. Obviously, x will be equals to plus or minus 1. So we're interested in the non-negative value. So our x, which we'll be concluding on, will be x equals to 1. All right. So Adil, can you make an attempt to question number 2 and let me know what your final answer was? So we're done with question number 1. It looks like you got it right. That's great. So attempt question number 2, and we can move on to another aspect of things. So the question said A is equals to, you can see the matrix we have in the bracket right there. We're told to determine the value of the constant lambda so that A plus lambda I is singular. Just 2 minutes. Give me an answer quickly. Do we have an answer already? No answer yet. Did I just see an answer? Y cube something. Let me see the answer again. Uh, Y cube plus 5 square plus 12 minus 8. When they ask you to solve, determine the value of the constant lambda. Is that the value of the constant lambda? You should be getting a perfect answer like lambda equals to something. All right. So have you been able to get an answer yet? Now, if you're going to solve this question number 2, one of the basic of what you must know is the use of this word is singular. So guys, the first question I want to ask you is, what does it mean when they say something is singular when you're dealing with matrix? Can anybody answer that quickly? What does it mean to talk about something being singular? Okay, so the thing is, when you say a matrix is singular, that means the determinant of that matrix must be 0. So now if you look at what we have here, we have a 3 by 3 matrix A, and then we are told that we have a constant lambda. We are asked to find what value will lambda be for A. What value will lambda be for A plus the multiplication of lambda? That's of course a constant. So, and don't forget, this is a constant, not a matrix. So that means what will be happening here is what we call scalar multiplication in matrix. Because we know I being an identity matrix, we know that I is always going to be 1 0 0 0 1 0 0 0 1. We know this quite alright. So when you are saying lambda times this is what we call scalar multiplication in matrix. So obviously the first thing you want to find is this expression. You want to find the value for this expression before you then go on to express these other aspects of the question. So lambda times I will obviously be, this is what we call scalar multiplication, where you'll be getting A plus, of course, you multiply each of the elements of this identity matrix with the scalar. So we'll be having lambda 0 0 0 lambda 0 0 0 lambda. So the next thing to deal with now is the addition of A with this scalar multiplication. So you want to go on to have your A plus this. That means if you can look at all the values, if you understand matrix addition, one thing that happens under matrix addition is the only criteria for you to be able to add two matrices together is that the two matrices must have the same dimension. They must be of the same order. So thankfully we can see that this is a 3 by 3 matrix. This is another 3 by 3 matrix. So obviously A being a 3 by 3 matrix can be added with this scalar multiplication. So one of the things we want to do next is to add each of the elements. That means this minus 4 now will meet with this lambda, and this -4 will meet with 0, and 4 here will meet with 0. That's the way you make you do matrix multiplication. Let's try and do the sum here. Of course, this will be -4 plus lambda. We cannot put a final solution to that, so we have to write it like this. All right, then we have -4 plus 0. Don't forget we are adding them. -4 plus 0 will be -4, so we have -4. Then 4 plus 0, we have 4. All right, now we have -1 plus 0, -1. 0 plus lambda, that will be lambda. 1 plus 0, that will be 1. -7 plus 0, that will be -7. -6 plus 0, that will be -6. 7 plus lambda, you have to write it as 7 plus lambda. All right, so this is the resultant when you added matrix A with the scalar multiplication of lambda with the identity matrix I. Good. Now we can then go on how to tackle the other side of the question. We have to determine the value of the constant lambda. You can see the constant lambda now, so that this A plus lambda I, which is this right here, is singular. So if this is singular, what you have to do now is to go on to express the determinant. That means we're going to say, if this was the meaning of this is that I told you use the straight bracket, the line bracket, when talking about determinant. So the meaning of this is that the determinant of this equals to 0. This is just it. So I believe now you can go on now to find the determinant of this and equate it with 0. Doing that will give you your value for lambda. So let me give you about 2 minutes to get that done quickly. Once you're done, I would like you to start tackling this. If you are done on time, you start tackling these 2 questions. If you're done with this question, start tackling these 2 questions. But let me be done with this first. All right. So I'm believing that you are still trying to solve this question. So I would love to see the answer of this. And after this, I would love to see the answer to the trigonometry question. Do we have an answer yet for question number 2? Okay, let's try and solve it together, all right? All right, so now that you've arrived at this point, so obviously what's necessary to do now is for us to go on to solve for the determinant of this expression of this matrix we're seeing right here. So for us to find the determinant of that, what we have to do is to carefully follow through on our methodology. Let's use the first method. The first method said obviously we're supposed to put in a plus minus plus here. So we are supposed to have plus minus plus based on the method we're using. So we'll be having plus, now we have minus 4 plus lambda. All right, now you know what we do normally in method 1, we isolate. Since we're dealing with minus 4 plus lambda, we are isolating column 1, isolating row 1. So we're left with this matrix. So we'll go on to find the determinant of this matrix. Finding the determinant of this matrix obviously will be lambda times 7 plus lambda. That will be lambda times 7 plus lambda minus 6 times 1. Minus 6 times 1 is minus 6. That will be times minus 6. So this is the first solution. Then we'll go on to do for minus. For look at it now. There is a minus here initially, then we have minus 4. So that will be minus, so that will be plus 4. You understand? Minus times minus is plus. Alright? So we have plus 4. Then we have to go on now and do the method I just discussed, where we isolate. In this case now we're isolating row 1 and column 2. So we're left with minus 1, 1, minus 7, 7 plus lambda. So you go on to find the determinant of that 2 by 2 matrix. That will be minus 1 times 7 plus 1. That will be minus 1 times 7 plus lambda. Sorry. And then minus 7 times 1. That will be minus 7. Because minus 7 times 1 is minus 7. Alright? So that's that about that. You just need to follow the method. No matter whatever the expressions you are dealing with, just follow the method, you wouldn't go wrong. The last but not the least aspect is for us to do for plus 4. So we have, let me use that on a different line. So we have plus 4. Then we'll open the square bracket again. So we are isolating row 1 and column 3. So we're left with minus 1 lambda minus 7, 6, minus 6 rather. That's minus 1 times minus 6, that will be 6 minus 7 times lambda. That will be minus 7 minus 7 lambda. Right? Does it make sense? Okay. So you can see how very patient you have to be able to get your answer here. So this is the first line of action. Then you want to go on now to express it rightly now. That means you want to open everything. So I would start to open everything even using this whole line. So just follow through. This will be 7 lambda plus lambda square. Alright? 7 lambda plus lambda square. 7 lambda plus lambda square. And this will be plus 6 because minus minus is plus 6. Good. So I can have this like this now. Let's do for this other side. Let me bring this closer. So we have plus 4. And then we'll open our bracket. Let's see what will be there. Minus 1 times 7, that will be minus 7. Minus 7 minus 1 times lambda, that will be minus lambda. Minus lambda. Alright? Minus times minus will be plus 7. Alright? So let's do this last side of things. Plus 4. 6 minus 7, that will be 6 plus 7 lambda. 6 plus 7 lambda. All right. I believe that looks clear. Now we can go on now to open the rest of our brackets. That's the other side of things. Now we want to open this with this. So obviously we'll be having minus 4 times. You use minus 4. Of course, this plus is no longer needed because plus times minus is minus, plus times plus is plus. So you can just have it like this now. It's still, if you want to leave it there, it's still the same thing. All right. So now we want to have, you use the first, that will be minus 24. Then we go on to that of lambda. Lambda times 7 lambda, that will be plus 7 lambda square. Lambda times lambda square, that will be plus lambda cube. Lambda times 6, that will be plus 6 lambda. Alright? I believe you can follow through on what we're doing. This is how you tackle the question carefully. So now we're done with this first side. Let's do for this other side now. We'll do, of course, one thing I can notice here is that we have minus 7 and 7. So obviously it looks like this will be dissolving because plus this will be dissolving, so we'll be left with only minus lambda. So 4 times minus lambda, that will be minus 4 lambda. All right, good. So we're left with this. We have 24. 4 times 6 is 24. 4 times 7 lambda, that's 28 lambda. So the next course of action now is that we want to see how we want to bring like terms together. But look at, guys, look at something happening deliciously here. I see minus 28 lambda here. I see plus 28 lambda here. Graciously, I can eliminate that because that helps my work. I'm looking for how to dissolve this in such a way that I have little or no, in short, very little work to do. I can also see minus 24 here. I can see plus 24 here. Graciously again, I'm going to take this out. All right. Is there any other thing that can go out that way? It doesn't seem like it. So let me try and bring things to a bit more clearer perspective. I can see lambda cube here. I want to use that as my first value. Obviously, because you want to always have your expression having the highest power as the first value. That's lambda cube. I have lambda square, I have lambda square. Let's try and find the solution of this. Minus 4 lambda square plus 7 lambda square. That will be plus 3 lambda square. Alright? Because 7 minus 4 is 3. Good. So that is done. So we're left with 6 and 4. 6 lambda minus 4 lambda will give me minus 2 lambda. Now do not forget that because I wrote the expression here, this is singular. This, don't forget, what we're doing right here is just the determinant of this expression. The a plus lambda I, this is the determinant. What we have done now, this lambda cube plus 3 lambda square minus 2 lambda is the determinant of a plus lambda I. That's what we have gotten. This is the determinant. So, but you are told to determine the value of the constant lambda so that a plus lambda I is singular. The meaning of that is so that the determinant is 0. Now that means we have to express this determinant being equals to 0. That's what we satisfy this side of the question. So at this point now, I believe you all have an idea of what to do. One of the best course of action here is to have your lambda factorized. So you're left with lambda square plus 3 lambda minus 2 being equals to 0. I'm sure you can see that clearly, being equals to 0. So what you want to do now is to, I believe I can rough this up at this point. So you want to do it, you want to split this expression to be lambda equals to 0, then lambda square plus 3 lambda minus 2 equals to 0. So you want to go on now to solve this quadratically. Can anybody give me the final value for this quadratically? So I believe this is factorizable. You can use factorization method to solve this. So can I get an answer very quickly? What do you say is the answer to this quadratic expression? Do we have an answer yet? You can solve this. You should be able to solve this quite easily with quadratic expression. And the factors you're looking for there, with factorization rather, we are seeing obviously what can you multiply together to give you 3? And sorry, what can you add together to give you 3? Multiplying to give you 4. Sorry, multiplying to give you 2. Hopefully I've, oh, sorry, I did a mistake here. It is not, this was, I was looking at things and it was looking, 6 lambda minus 4 lambda is actually plus 2 lambda, not minus 2. That was why we are having an issue with factorization here. So it's supposed to be plus 2, plus 2. That will help. So that means our factors will be minus 1 and minus 2. Sorry, 1 and 2 rather. So we'll be having lambda square minus plus lambda plus 2 lambda plus 2 equals to 0. This will be lambda into lambda plus 1 plus 2 into lambda plus 1 equals to 0. So obviously our lambda, we'll be having lambda plus 1 and lambda plus 2 equals to 0. From here, obviously, you can see that the value of lambda will be minus 1 and minus 2. So we will have, we are told to determine the value of lambda. So lambda will be equals to 0. Of course, lambda plus 1 equals to 0 is the same thing as lambda being equals to minus 1. And lambda plus 2 equals to 0 will also give you lambda equals to minus 2. These are your final solution. Does it make sense? Okay. So let's go on to the next question, trigonometry. So we're done with matrix. Of course, there are still other aspects of matrix, but we just want to pick up a few questions in each of all these topics. So what is your solution to question number 1? This right here. This is question number 1 on trigonometry. You have to solve that expression. What do you say is your answer? So we have our first question on trigonometry in front of us. All right, so I'm still waiting for your solution on question number one, trigonometry. Of course, you know you have to make use of your identity. I think it's taking too long to answer some of these questions. This is quite a very simple question. Let's look at question number one. We have 2 cos square theta. So obviously one of the things you want to do right here is to ensure you bring every of these trigonometry ratio to just one particular one. So you want to see cos square theta, sine theta. You don't want to see those differences. You want to either have it as just sine theta. That means it could be sine square theta, sine theta. It's still okay. Or you just want everything to be cos theta. Whichever one works is what you have to do. All right. So looking at what we have right here, I see and I perceive clearly that it's easier to change this cos square theta because I know fully well from my identity that sine square theta plus cos square theta is equals to 1. So knowing that fully, I want to go on to interchange cos square theta for 1 minus sine square theta. So I have 2 into 1 minus sine square theta equals to 1 minus sine theta. Alright? So then I have 2 minus 2 sine square theta equals to 1 minus sine theta. So this obviously gives me a quadratic expression where I have minus 2 sine square theta plus sine theta plus 2. Of course, this plus 2 here, then I bring this here, I have minus 1. Everything equals to 0. So I can have this, I want to have, it's always good to start your expression with a positive number. So I want to have plus 2, I don't have to write a plus anyway. So 2 sine square theta minus sine theta, I'm multiplying through by minus. 2 minus 1 is actually plus 1, but because of the multiplication through by minus, it will turn to minus 1. Alright? So this is where you have to now solve quadratically. Now it's very possible for you to solve this way, but for the sake of ensuring that you don't make any mistake, I would always advise you take your sine theta being equals to x, because this is more familiar for everyone. So you'll be having 2, of course, if sine theta is x, that means sine square theta, which is the same thing as sine. Don't forget, sine square theta is the same thing as sine theta all square. And if sine theta is x, that means you'll be having x square. So this will be 2x square minus x, then minus 1 equals to 0. So we can go on to solve this using factorization method now. Trying to solve this using factorization method, you see that you'll be having two factors uh, in focus, and that will be what? That will be -2 and +1. So you'll be having 2x squared minus 2x plus x minus 1 equals to 0. You have your 2x into x minus 1, and you have your 1 into x minus 1 equals to 0. So obviously you see from here that your x will be equals to 1. If you look at this, you have your 2x. Of course, I want to be a bit fast, so x is equals to -1/2 and 1. So now don't forget that we had our sine theta being x. So that means we are saying sine theta is equals to -1/2, and we are also saying sine theta is equals to 1. Alright? So you have to solve this separately, and you have to use your idea on angle of any magnitude. So using the idea of angle of any magnitude, what do you have right here? You have, this is obviously sine theta equals to -0.5, alright? So using angle of any magnitude, you know, the first thing you have to ask yourself is, where is sine theta negative? Of course, using your quadrant, you remember that your sine is negative in both the third and fourth quadrant. So these are your quadrants of interest. This is the two quadrants that will bring out your value. Alright? Any other answer apart from what this third and fourth quadrant brings out will not be part of it. And the function, what functions inside the third quadrant is theta plus 180, and that of the fourth quadrant is 360 minus theta. So the question next is, how do we find this value for theta? To find the value for theta, what we just have to do is say theta is equals to arc sine 0.5. At this time you will be ignoring the minus. So theta right here, arc sine 0.5 So what is arc sine 0.5? Okay, that will be 30, right? Arc sine 0.5 gives us 30. So obviously you want to come back here to use the value of 30. That will be 30 plus 180. That will give me my 210, and that will be 360 minus 30. That gives me my value of 330. So for this aspect of things, our two values of theta is 210 and 330. Alright? So you want to go on and solve for sine theta being 1. Of course, in that case, you want to ask yourself, where is theta positive? Because we have positive right there. So where is theta positive? A very important skill to have. Theta is positive in the first and the second quadrant. Of course, you know the first quadrant, you don't have any function in there. You just have it as whatever you had initially. So what you want to do now is to go on and find your theta. Your theta here is arc sine 1, which will give me the value of 90. So obviously, for the first quadrant, I'm going to write this value there. Theta is 90. And then for the second quadrant, we have 180 minus 90, which is 90. So obviously, our final answer will revolve around 90. Happening twice, 210 and 330. Alright. So can you go on now to solve question number 2, which should be our last question on that trigonometry? Can you solve question number 2 quickly? All right, we have an answer already, right? All right. Okay, so let's see how we're going to solve this. So we have the question 7 sec squared theta being equals to 6 tan theta plus 8. Of course, you know the most important thing to do right here is to try to make them just one single trig function. So you remembering that our sec squared theta is equals to 1 plus tan squared theta. This helps me to be able to swap sec squared theta for 1 plus tan squared theta equals to 6 tan theta plus 8. So I have 7 plus 7 tan squared theta equals to 6 tan theta plus 8. Alright? So looking at this now, I can have, of course, rearranging the function properly, 7 tan squared theta minus 6 tan theta plus 7 minus 8 equals to 0. So I have 7 tan squared theta minus 6 tan theta minus 1 equals to 0. So for good practice now, we can decide to take x being tan theta. So we'll be having 7x squared minus 6x minus 1 equals to 0. So we can go on now to solve this quadratically. Alright, so if you decide to solve this quadratically, you'll be having minus 7x and plus x as the factors. So we have 7x squared minus 7x plus x minus 1 equals to 0. We have 7x into x minus 1 plus 1 into x minus 1 equals to 0. So you can see right here that we're left with 7x plus 1 and x minus 1 both equals to 0. So we have x equals to minus 1 over 7 and we have x equals to 1. Now we have to relate this back to our tan theta being x. So our tan theta will be equals to minus 1 over 7. We have to go on to solve that. And our tan theta will be equals to 1. So, of course, what you want to do right here is to ask yourself the same question. Where is tan negative? Because for this first one, we have a negative sign here. So where is tan negative? Of course, tan is negative in the first quadrant and also in the fourth quadrant. This is the two sides that makes tan negative. So now what, of course, you know, tan is not negative in the first quadrant. Sorry, that was a very big error. In the second quadrant, rather, the second and fourth quadrant. So we have 180 minus theta and we have 360 minus theta going on right here. So what's our theta? Our theta will obviously be arctan 1 over 7. Of course, I told you already at that point you'll be ignoring the negative sign. So if you find out arctan 1 over 7, you'll be having theta being 8.13. So you have to go on and use that in this expression. That will be 180 minus 8.13. That will be 360 minus 8.13. This obviously will give you the value of 171.87, and this will give you the value of 351.87. Alright, so that's that about the first aspect of things. But you want to also solve the other aspect of things that said tan theta being 1. So in this case now tan is positive. So where is tan positive? Tan is positive in the first and in the third. In the third we have theta plus 180 going on there. So we have to go on to find what theta will be. Theta will be arctan 1. What is arctan 1? Arctan 1 is 45. So we have 45. So we have 45 plus 180. That will give me a value of 225. So theta will be 45. So our final values will obviously be, for the whole question, will be 45, 225, this 171.87 and 351.87. So this is how you deal with questions on that children. So let's run quickly to binary operation quickly because of time. So let's see how to deal with questions under so I'm sure you guys was able to flow in both topics we have done. So let's run quickly to binary operation and let me see how much you are able to conquer that. So given that a star b is equals to 1 over 2 a plus b. All right, this is the operation on which this binary operation is defined on. So the question I want to ask you is this operation associative? Number one, I want you to do for, is it commutative and is it associative? Is it commutative? Is it associative? So that's the question. Can you do that quickly? I want you, just let me use this to introduce you into binary operation. Of course, this is just introduction. Let me see how you fare with that question. And I would be dropping another one side by side. So the same thing, I want you to show if it is commutative or associative. Do we have an answer yet? Is it commutative? Is it associative? Oh, okay. Okay, let's try and solve and let's see if what you guys are putting out here is okay. For the first one, you know the function for it being associative. If it is commutative, of course, you know that a star b must be equals to b star a, right? So that's quite very simple. If this thing is commutative, then a star b should be equals to b star a. And I always like to say this because my own method, I'm sure you guys know that well enough. I love to, as much as possible, use languages that you guys can relate to. So what I always see this as is like first second is equals to 1 over 2 first plus second. Now, if you say A star B, this is it obviously here. For you to find B star A, that means you're going to say B star A, of course B now is the first, 1 over 2 second, that will be B plus A. So obviously you want to ask yourself now if these two things are the same thing. So if you look clearly well enough, you can see that this and this are actually the same thing. So it's very obvious that we can conclude that it is commutative. Now the question is it associative? Of course, for being associative, I'm sure you know that the theory for associativity is that A star B star C should be equals to A star B star C. I'm sure you agree with that, right? So if this is the case, we have to go on now and go and find, first of all, what is B star C. And don't forget, whatever you define your expression on, like you define it on this now, is what you will always use to tackle any other thing. So for you to find B star C now, you have to come back and use the operation on which the function was defined on. Sorry, the function on which the operation was defined on. Now this is B star C. So this will be 1 over 2 B plus C. Alright? So now B star C is now this. The whole of B star C is this. So when you want to now go and find A star B star C, it's as good as saying you are finding A star, this whole thing, 1 over 2 B plus C. If you can understand what's going on here. So B star C, we have gotten it to be this. So we are still solving for this side first. We have not started solving for the right hand side. So for the left hand side, B star C is actually this. So A star B star C will be A star all this, A star all this. So the same thing, you have to go back and use your original function to tackle this. This is the first now, this is the second. That's just the meaning of that. So the first now is A. So obviously A star B star C will be equals to, A is still the first one, so that will be 1 over 2. Your A is still the first. Don't forget, this is your second. That means what you have as B here, this is what it will be. A is still A here. So that will be 1 over 2. Your A is still A. That will be A plus. Now your second will be 1 over 2 B plus C. This is it. So this is how you tackle the answer for this left hand side. This is the answer. Of course, you can break it down. We can probably break it down very soon. But let's just leave it there now, and let's try and tackle the right hand side. Don't forget, the theory for associativity, we said we are trying to prove that these two are, if these two are equal, that means if what we got as our answer here is the same thing as what we got as our answer here, then we'll say it's associative, right? So let's try and even get what we have gotten for this. Let's try and get for this. So this says A star B. We already know what A star B is, so we don't need to do so much there. So that means we are saying A star B was this. So that means we are saying 1 over 2 A plus B star C. Because A star B is this. Look at it. A star B is this. A star B is this. Then star C. Alright? A star B star C. So this is the first now in this new expression. This is the first, this is the second. So you have to come back to your original function. Your function said first times second, first star second equals to 1 over 2 first plus second. Now this is the first, this is the second. That means this will be equals to 1 over 2 first. First is this now. 1 over 2 A plus B. Then second plus second. Your second was C plus C. This is it. So this is the answer to the right hand side. Now, the question I'm going to ask you now is, are these two things the same thing? Because this is the left hand side, this is this, and this is for this. So are these two things the same thing? That's the question. Are they the same thing? Now, for you to be able to get that answer, I would advise you to try and uh try and solve this much. Of course, if you are very smart and you are able to see things much quicker, it's easier to still see that they are not the same thing. But because for the sake of balancing everything, let's try and break this a bit further. So let's try and get this. This will be a plus b plus c over 2. All right, and this will be equals to 1 over 2. We have to find the LCM. The LCM being 2, we'll be having 2a plus b plus 2. I'm finding LCM. That's all I'm doing here. There's nothing I'm doing different. All right, so of course this will give me 2a. Sorry, let me take this off. This will give me 2a. This is this one, 2a plus b plus 2. That will be 2a plus b plus 2. 2a plus b plus 2 over 4. That's the uh sorry, not 2 plus, sorry, c. I was writing 2 instead of c. Sorry about that. So look at this, 2a plus b plus c over 4. That is the answer to the left hand side. All right, now we have gotten the left hand side to be this. Note this, look at it very well. Let's try now find for the right hand side. For the right hand side, you have to be very careful. Do the same thing. We have 1 over 2. The LCM now, of course, this is a plus b over 2, so that will be a plus b. Of course, 2 will be the LCM plus 2c. If you just do the LCM, there's nothing we are doing other than doing the LCM. This will be a plus b plus 2c over 4. Now, I want you to ask yourself, these two things, are they the same thing? Of course, the answer is no. So that means, even though our first result, we determined that that was associative, was commutative, it is actually not associative. All right, good. So we are done with that. That means you guys know what you are doing. Now let's see for the other one now. This is the other question, by the way. So can you do for this one? Have you gotten an answer for this? All right, so okay, so let's see how we define this if it's okay. Okay, now look at the second question. This second question for commutativity are quite very simple. Remember that x star y must be equals to y star x. If it's not the same thing, then that means it is not commutative. So you have to ensure that this is established, right? Good. Now let's try and see. We already know our x star y. Let's see y star x. Y star x will be equals to, of course, y star x. This is first and second. Y star x. That will be equals to y. The first now is y, not x. The first is y. The second is x. So that will be y plus x. X is the second year. Alright? I'm sure you understand what's going on. Minus the that's why I said I always like you to understand this thing as first star second equals to first plus second minus first times second. It's better that way because that way it is easier. It is easier to be able to comprehend what's going on. First, second, just see it as, instead of seeing it as x, y, or something, see it as first. That means the operation is saying whatever your first is with your second is equals to first plus second minus first times second. All right. Now, if you have, of course, x star y is still the same one. For you to now find y star x, that means in this y star x, your first now is y and your second is x. So obviously, this is your first. Don't forget, this was what your first was here. So first star second was first plus second. First is y now, second is x. That will be first being y, second being x now. Because your second here is x. Then this was your first is y here. So that will be yx. This is going to be the expression for your y star x. Now, let's now ask ourselves the question. Is x star y equals to y star x? That means what you have here and what you have here, are they the same thing? Guys, are they the same thing? What do you say about, are they the same thing? Of course, if you can look fair enough, you can see that even though you have y plus x and x plus y is still the same thing. And then xy and yx is still the same thing. So obviously we define this as being commutative. That is good, right? All right. Now, what is the next thing we have to do? We have to prove for it being associative or not. So what is our expression for us to determine if something is associative or not? Right? We define it as this. That means x star y. The way you do this, you just say you introduce a new something. Look at, it's more like I just wrote. Look at what I just did now. For those of you that are probably you're finding it hard to understand what's going on here. So you just say you bracket this, and then it's more like you isolate this last two, then you isolate the first two, the first two here. So if these two are the same thing when you are done solving, then it is associative. But if they are not the same thing, it is not associative. All right, fair enough. So let's see now. We want, for us to solve this now, you know the importance of solving your bracket first in anything mathematics. You want to first solve your bracket. So we have y star z. So we have to go and find y star z first. Y star z. So what will be y star z? First is y now, z is second. So the same principle. Using you must always fall back. You must fall back to your initial operation, the initial function on which your operation is defined. That's the basic and the key to all your answers. So y star z will be equals to y, of course, this is your first now, z being your second, y plus z minus yz. This is your y star z. Now, you now want to go on now and find, don't forget, this is what you're interested in. This is the left-hand side you're interested in. You will have to find the left-hand side and also find the right-hand side. So we are not yet done finding right left hand side. We have only found this aspect. We have to go and find everything. So we need to now go on and find x star y star z. Now you have gotten y star z as this whole thing here, so that means you'll be having it as x star. Instead of writing y star z now, you can write this whole thing here now, y plus z minus yz. You can see it right there. All right, so now again you have to always revert back to your initial function. This is the operation, this is the function on which the operation is defined. So anything you are doing under this question must always come back to this initial expression, this initial function. All right, so this is your first now, this is your second. So that means we'll be having our first, second. So our first, second, our first now is still x, so we have x plus our second is no longer y now, our second is this whole thing, so we have y plus z minus yz, then minus first times second now, which will be y plus the same y plus z minus yz. So this is what our left hand side is. So you can go on to solve this perfectly. That means you open all the brackets, you'll be having x plus, of course, y plus z minus yz. Then you want to go on to have minus xy. Of course, probably let me just put this in a bracket first and just open this. You know why I'm doing that, right? Because I'm trying to ensure that I don't miss the minus with anything. So I have xy. I can do it without doing that, but for the sake of everyone watching, I want to be a bit. So I have minus xyz. So my final answer for the left hand side will obviously be left hand side now will be x plus y plus z minus yz minus xy. I'm opening with the minus now, minus xz, then plus xyz. So good, this is our expression for the left hand side. All right, great. Now if we have gotten the expression for the left hand side, we have to go on and now find the expression for the right hand side. This is left hand side. Let me indicate it very clearly. This is left hand side. So we have gotten that for this. This is the left hand side we're referring to. We have gotten this now. We want to go and get this. So how do we get this? Of course, we have to follow the pattern also. We have x plus y. We already know our x plus y. Good. So we want to find x plus y, x star y star z. This is what we want to find. This is the left hand side we want to find. So x star y is already given. We already know that one, so we don't have to go and be trying to get it again. So you have to fix in all these values of x star y into this place now. X plus y minus xy. So it will be, instead of writing x star y now, we'll be writing this one now, because x star y is now this. So x star y star z. All right, so that's what we want to go and solve. Don't forget, again, as I said already, you have to always revert back to your initial function. So this is first, this is second. So you have to go on now to take this as your first and take z as your second. So in this case now, using the expression, you'll be having x now, the first one now is this. That will be x plus y minus xy. First, I put it in a bracket because it's a compound expression, plus y, not plus y now, plus z, sorry, because our second is z, plus z, then minus first times second, that will be x plus y minus xy times z. So this is what we want to solve. If you are done solving this, you would have gotten your value for the right hand side. So let's try and solve that. Of course, I want to open this up. I have it as x plus y minus xy plus z. Okay, minus, then I want to multiply this x times z. Again, you know what I want to do. I'm sure you know what I want to do. I want to put this first in a bracket so that I will be very exact. Plus yz minus xyz. So this will leave me with x plus y minus xy plus z minus xz minus yz, then plus xyz. So we are absolutely done with our with our right hand side. So this is right hand side right here. So the next thing for you to do now is to ask yourself, is the left hand side equals to your right hand side? Of course, I told you already, once this is the case, it is associative. If it is not the case, it is not associative. So let's check it out. X, x, y, y, z, z, y, z, y, z, x, y, minus x, y, minus x, z, minus x, z. Guys, it is associative. We can conclude now that what we have right here is associative. So it is associative. So can you see how, of course, we are just revising every topic on whole one. So we see how, let's quickly run to another aspect of binary operation before we jump out of this place. So let me just drop this question, just I don't expect nobody to miss it, but just for the sake of ensuring that everyone so if we have a star b being defined on this function b squared minus a squared over 2ab. So the question is for you to find minus 3 star 2, and I want you also to find 1 over 2 star minus 1. All right. So what's your response to this question? It's a quick one. We're supposed to use like probably just 2 minutes to answer this.